dry ice reacting with water. It's a pretty cool experiment, but you got to be careful the way you handle dry ice. I should be wearing my protective gloves, but I'm touching the plastic. And there you go. That's dry ice. Watch what happens. Here we go. A little bit of water. And look at that. Why do you think that's happening? Why do you think? You think that's smoke, but it's not. It's not smoke. I don't know if you can see there it is. That was a good one. So this is what they use sometimes in movies to create fog. They use this in haunted houses, and it's a cheap and easy way to do special effects practically. But what do you think's going on? Why is there fog? How is that happening? Well, it's a transition of energy, because this right now is colder than the water coming out of my hose. And what's happening is energy always goes from high to low, because the universe and the world, everything, nature, wants to be in balance. Oh, there's a good one. That's a good one. Okay? You got to understand, everything goes from high, there we go, high to low. They try to get into a balance. And that's what's going on here. The very cold ice, this water is cold, but it's not as cold as that. So what's happening is every time the water touches that ice, the ice is absorbing the energy from the water, and what you get is water vapor. Oh, that's a good one. And look at the fog. Now, I can't touch dry ice with my hand. Nobody should do that. You'll get frostbite, okay? If you don't know what that is, go see A Christmas Story. The scene where the guy sticks his tongue on the pole. Oh, look at that. But, look at that. Wow. Looks like a little swamp, like a little fog. That's pretty cool, right? Yeah. So, there you go. And notice that the ice is still mostly remaining solid. Okay? I'm just going to let the water run on top of it right now. I'm not going to do the spray. And look. And notice that ice isn't melted yet. And it's causing all this water vapor all around it. Why do you think that's happening? Look how entertaining it is just to put water on dry ice. And notice, if I put faster water pressure on it, there you go, versus just dumping water on it. There we go. And this is a nifty way to make a fog machine, smoke effect. You can use this in your science fair projects. Now, I am going to pick it up with plastic. Okay. Ooh, that's cold. Hold on. Let me go get my thermometer, my meat thermometer. Okay. This is my digital thermometer. Okay. All right. Let's see what the temperature is. Ooh, this is cold. Look at that. 12, 7 degree, 1 degree? Negative 5 degrees. I don't know if you could see that. Look at that, negative 30. That's how cold this dry ice is. So if you touched this right now, not good. Definitely not good. But look at that. This part of the ice is oh, look at that. There it goes. Wow. And notice the mist it's making right now because it's laying in a puddle that I put around it. So basically, long story short, this water, even though it's cold, here, let's see how much, let's see the temperature of the, ooh, that's a nice one. Look at that reaction. Now the question is that a physical reaction or a chemical reaction? Remember, a physical reaction is where you do something and to the item and it stays the same. Like for example, a physical change. I mean, like watch, ready? If I rip this plastic, hold on. Okay? I ripped off this piece of plastic, sorry, right here. That's still plastic. That's a physical change. Okay? It's when you take something, like watch now, that's a physical change. This is still a piece of grass, it's still grass. If I light it on fire and it becomes ash, then it is not the same material that you started with. That's a chemical change. So examples of chemical changes are decomposing, when something decomposes, rust, oxidation, which is basically the same thing, okay? Lemonade, making lemonade and chocolate milk, okay? But the thing is that if you let that stuff sit out and it separates into milk and chocolate again, that's a physical change. But usually when you end up with something different than what you started with, that's a chemical reaction, chemical change. So look at this. Oh, you can see the bubbles. Why do you think it's bubbling? You see that? Let's see what happens if we touch the bubble. Notice that there's reactions going on. There's a crater right in here. Ooh, look at that. And look at this. This bubble isn't moving. Look, see? This water is staying where it is because the cold dry ice. Okay, now if I move it around, oh, look. Notice the bubble is now starting to freeze the water. Okay, there's the temperature change. Oh, wait, do you hear that? Oh, look. Oh, you almost saw it. Hold on, let me see if I can, because I know sometimes if you take metal and you put it onto dry ice, it'll actually, yeah, watch. If I can get this, it'll bubble. Let's see. Let's see if it'll bubble. Yeah, did you hear that? I don't know if you can see the bubbling. Oh, look, there's that original bubble now. Let's take that, look, see? Anyway, my longest video so far, and all I'm doing is playing with dry ice. Students, do not do this without your parents' permission and without safety. I know I'm not doing the best here, but I've handled dry ice tons of times. I know to keep my distance. Okay? I'm just letting it melt because I got Omaha steaks today. But look, I moved that away. You can see the bubbles. You can see the bubbles right there. Look at that. Made a little crater right there inside the dry ice. You can see it right there. It's bubbling. Ooh, there's a good one. Right there. Ooh, did you hear that noise? Listen again. I don't know if you can hear the squeaking, but that's from the metal. I'm just letting the metal. Let's see what happens if I put this on it. Oh, you hear that noise? That's the noise coming from the metal and the ice. And if you can look carefully, ooh, there's a good one. And if you look carefully, you can see the grooves right in there. So that's a physical change right there. But I got a nice little crater going right there, and it's bubbling. All right, fun with dry ice. Okay, remember, do not play with dry ice without parent permission and safety equipment. Okay, the only reason why I'm not using safety equipment right now is because number one, I don't have it, and Number two, I've handled tons of dry ice before when I used to work in restaurants. So, unless you're experienced, do not mess with it. Oh yeah, never put dry ice in a sink because it can really mess up your pipes. Okay? I learned that. Okay? But I've seen some people do that. The best is to probably put it in a bucket and see what happens. I mean, look at that smoke. Look at that. How cool would it be if, like, you know, my son's action figures were in there and it would be like, oh my God. Oh no, look at that. Ah. Now, if you look carefully here, I'm going to try to put a hole right through that. I'm just putting it right there. Making a nice little puddle. Yeah, get it nice and wet. There we go. Look at that chemical. It's basically, it's a physical change. It's just turning into water vapor. It's still water, or whatever this material is. But look, can you see that little smoke right there? Can you see that? You see the bubbles? Ooh, let's see if I can put some sweat on it and let's see what happens. No, nothing. All right, but now notice, look at these bubbles. They're not smoking anymore because they are the same temperature. Now, this has been out in the sun. Let's see what happens when the metal touches the dry ice. It should make a noise. You hear that? I'm not scraping it. Okay, what I'm going to do right now is I'm going to put the thermometer in there. I'm going to go get a set of keys. Actually, no, I'm going to go get I'll get a utensil. All right. See, this is what some teachers do when they're quarantined. Okay? We just get bored and we do experiments. It's a lot of fun. Ah, here we go. My keys. So here we go. And this will be the last thing I do. Because who wants to watch somebody play with dry ice for 15 minutes? All right, the temperature. Look at that. Remember it was negative? Remember it was negative? And my foot is next to some of this liquid. And it's cold. All right. Oh, look at that. Look at that. The water bubble froze. Oh, look what it's doing to... Why do you think that's happening? It's starting to freeze. Look at the temperature. What is freezing? 32 degrees Fahrenheit. Look at that. 32 degrees. Oh, there it is. I don't want that to touch my foot. But yeah, that's pretty interesting. All right. There's another... And see, the water and the dry ice are now achieving the same temperature. And look what it's doing to the water. It's making like little bubbles right there. Let's see what happens if I put my key here. It should make a noise. No? All right, let's try this key. You see that? The metal, okay? There's got to be something in the composition of this metal. Ooh, now that key is ice cold. All right? Yeah, that's interesting. All right, let's see if it makes that noise again. And keep your eye right here. It should make a groove. That would be a physical change. And the noise stopped. Ooh, that's super cold right now. And the noise stopped. Ooh, did anybody see that? How it went from... Yeah. Let's see what happens if I put a spoon. So, oh, watch what happens to the frost when I put my spoon there. Look at that. Why is the spoon making that noise? What was going on? Well, I moved the spoon. Now the whole spoon is ice cold. Let's see what happens if I hold on to it and give it some heat. All right. Because what I'm thinking is, the higher the temperature is, the louder the noise is going to be. Meaning that the energy transfer is going so fast, it's going to make a noise. Ready? I've been holding this in my hand. Let's see what the temperature is. What I do with my thermometer. Here it is. Okay. My thermometer says it's 91 degrees out. 92. All right. Here we go. Ready? Set. Look at that noise. Look at that little bubble. Look at this. Look at this little scoop of dry ice right there. So that's interesting. Oh wow, look what happened to the grass. It froze the grass. Look at that. Froze the grass. That's crazy. That's crazy. You can hear the noise. It's crazy. Let's see what happens if you put dry ice on top of dry ice. Oh wait, it was frozen to my spoon. All right, here goes nothing. Should make a loud noise or a lot of smoke right now. There we go. Well, we call it smoke, but it's not real smoke. This is vapor. And whatever dry ice is made of, it's becoming vapor. So if this turned into if there was something left behind when the mist goes into the air, that would be a chemical change because you're separating the materials. That's not what's going on here. Wow. It's the little things. I feel like the Bob Ross of science right now. There's no mistakes, just happy experiments. That's what I used to say as a teacher when I taught science. All right, here are my keys. Now, my keys have been out in the sun. Let's see what their temperature is. Okay, right after it made the noise. That's the temperature of my keys right now. Okay? Watch this. Ready? You hear that noise? Why do you think it's making noise? What's making the noise? Where's that noise coming from? You know, a lot of movies show safecrackers using like a freezing spray. And sometimes this is what it is. All right, let's test the temperature. And look at the temperature dropping of my key. From 90-something degrees. This is why you can't touch it with your hands. You will get frostbite from the energy transfer of your body being at 98 degrees. Okay? Now, notice how it's stabling out at 78. Reason is because that's its specific heat, I believe. I got to double check that. But now it's starting to get warmer because the key is colder than the air around it. So the key is going to absorb energy from the ground right here and the air that's all around it. And look at the temperature already. Going back up. As I said that it went down, but I think that's because I moved it. All right, let's see. I'm not scraping it. I'm just putting the keys on there. Interesting noise. Ooh, this is ice cold. Ice cold. And look at the grass. Believe it or not, you could cause a fire like this. The energy transfer. That's what burns are. A burn doesn't just happen because of something being hot. Okay? Burning, there's cold burns, there's all kinds of burns. Oh, that's a good one. Look at that. Wow. And notice, if I had a regular ice cube, that would definitely be, what do you call it? Melted already. All right, I'm going to try to fill up that little, yeah, look, see that little hole right there? That little hole right there? It's smoking. Wow. Fun with, oh, this spoon has been out here for a while now. Let's take a look at the temperature. The spoon. It's about 90 degrees right now, that spoon. Yep, here we go. Look at that. Notice how quick the temperature drops versus how quick the temperature rises. This is showing you that the ice is absorbing the energy, and they're going to try to reach what's called homeostasis, where things are balanced and equal. When this thing stabilizes, that means that the spoon and the dry ice are going to be at the same temperature. Temperature's still dropping. Notice the spoon. Yeah, look at that. The spoon's probably frozen to this. Nope. But look at that. You can see the frost. Wow. All right, that's me playing around with dry ice for 20 minutes. Have fun.